Anyway, I guess the point was to make a video to show everyone around the chunking work that I've been working on. Yeah, I feel like I've only really just gotten it working, but I'll share my screen and we'll see what I can do. It's a new setup, so I'm not sure if sharing screen is going to work. It did ask me for some permissions before, but we'll see what happens.
Yeah.
Sweet. My windows are all out of whack. How do I move this thing? Impossible. Oh yeah. Um, um, so, how do you think the best way for me to show this? Probably should have thought about this, but so basically, um, I guess I'm looking. Well, yeah. I guess I can start in the end. So the indexer is what's doing the Gitly calls and getting all the individual files out. And my goal with the chunking is to um, break those down into chunks that are smaller than whatever arbitrary token limit that we set, so that we can still have, so that we can use it for context for the LLMs, whatever. And so this the Elasticsearch indexer is triggered by Psychic jobs, and it's kind of run and it's run in the special chunking mode, and then the chunking mode we if I can find it, what's here? Oh my gosh, everything says chunk. That's really useful. Wow, yeah, that's not very useful. Yeah, here we go. So here we use the chunker. And this is what I've been working on, this chunker here. So uh, the problem that we have is that we want to be able to run chunking that is like taking an input file and determining how to subdivide it so that it's small, so that each of the divisions are smaller than some limit. We want to be able to run that on the client side as well, like in your IDE or whatever, or or whatever. And in order to do that, we have to use Rust and tree sitter. So we can't just have all the implementation in Go, which is a bit unfortunate because that means we have to go through FFI. And so I wrote this little interface, which we're importing here, from the code parser. That has a few tricks as well, because when you're going through FFI from Go, you have to kind of tell the garbage collector that you're handling how you're handling the memory. So if it'll let me go in here, I'll talk about it. It makes it tricky because you're basically left to your own devices. Like there are but the basic idea is that we're trying to take these we receive the file rather than getting file names, we receive like the byte array, just the raw bytes. And the way that the chunker works is it tries to just return pointers inside of that byte array so that we don't end up having to copy anything. But we have to tell the Go allocator that we are doing that, and the way we do this is through this pinner. You can see here we unpin here. Where's the Where's the actual pinning go? Oh yeah, yeah. Yeah, so when we add files, we dig into the string, we dig into the Go string so that we can find the point, so that we can, yeah, so that we can tell the Go garbage collector that um, we need this for as long as until it's unpinned. And it also means that the Go garbage collector can't rearrange memory or anything like that, so it can't be moved. Yeah, so I'm sure there's some performance impact for that, but yeah. So anyway, and these all end up going into these Seago pools. So this is like our high level API, which is like the Go, but then it goes deeper than that into the C API, and the C API is provided by the parser, but it is written in Rust. So I'll just quickly find that. Yep. Oh yeah. So yeah, what do we call it? C bindings. Yeesh. Yeah, we just have this at the moment it's not very well organized, but basically inside of the GitLab code parser, we have a crate, and this crate just generates the C bindings for um, everything, well, presumably everything in the parser, but at the moment it's only chunking. And yeah, this is really complicated as well because Rust adds a lot of protections about how you are sharing memory, like borrowing and stuff like that. And you pretty much have to tell it that it's okay because we are passing it off into C memory space. Um, so you'll see a lot of this, a lot of marking with unsafe and yeah. Um, but basically we in these constructors here we are allocating memory in Rust and then passing the pointer to C, which eventually is used in Go. That's what so these boxes will be doing the boxes doing the allocations, and then this is just getting the raw pointer so that we can pass that raw pointer around. Um, and it does mean we have to be a bit careful. Where is it? Um, to free the memory up again at the end as well. Anyway, I don't know how useful this is to. Yeah, because usually what happens with a box in Rust is that when it goes out of scope, then it'll automatically deallocate like the memory that it's allocated. So all that ends up happening here is that we like take the raw pointer, turn it into a box, and then it goes out of scope so that it gets deallocated. So yeah. Um, yeah. Okay. So this is pretty much all the FFI is. It's kind of a frustrating aspect of this project is that because of this kind of obscure requirement that we want to be able to possibly run this chunking on the client side as well, means that we're having to kind of develop the API and develop this FFI all up front, which makes it a bit more tricky. Anyway, and so for the chunking itself, how we decide to make so there's kind of two strategies. And I guess we'll talk about this one first. So there's two strategies for how we're talking about how we're going to do the chunking. One is that we chunk by bytes, and the other is that we parse the code and then we find interesting parts of the code and we split on those points instead. So when we talk about the size chunker is counting the bytes and then saying, and then so like doing it in units of 1,000 bytes or whatever. And then the code parsing chunker is parsing the code and then trying to find interesting parts of the code. So we do that through we basically just check the types of nodes they are and add the start or the end as a split point. So that's like a point where it might be a nice place to put the edge of a chunk. And then the strategy we have for now, and maybe we want to think about different ways we could do this, but for now we just put as many of these split points into a chunk as we can. To make largest chunks possible. But it might be like depending on how like there's a lot of aspects of this that I don't really understand, like how the chunking will affect the output of the LLM. So like it might be advantageous for us to have less of these kind of split points and I'm not really sure. Or like prioritize specific ones, like maybe we just want to have chunks that just have functions in them, for example. It's not really clear. But anyway, this is how we're doing it at the moment. So we basically just go over the entire tree and take these split points. The reason we ended up with this strategy where we build this list of split points is because the AST, the syntax tree for tree sitter, the nodes can overlap, and that means that you can't just walk the tree and like you can't just consume parts of the tree because you'll later come to a node that overlaps with parts that you've already consumed, and so it gets really hard to do all the paperwork to figure out what parts of the file you have used up and what parts of the file you haven't. So this way we can just make the single list where these are kind of like points in the file, where we can choose how far into the file to split. Yeah. I guess that's all the code, and I can show you it working as well. I actually only just fixed a bug, so which I've got on my browser here. But yeah, let's have a look here. So the way that I've been running it, which you can get from this comment, which is nice, is basically just basically running the indexer. I guess this is kind of like how browser would run it, but I'm just running it manually. So yeah, copy pasting stuff. And I've got it set up to a local repo that I've pushed the GitLab repo to. So yeah. So I guess the main parts here are like the project ID and this relative path. And I can run this. The output's not that exciting, but it basically does chunks of 1,000 file over and over. And yeah, I think that's pretty much it. Yep. I don't know how long it takes. It's like a couple of minutes.
About 3 minutes.
Yeah.
30 minutes. Yeah.
Or
yeah, it's like or actually like 100 plus seconds, so maybe not 3 minutes.
Um, yeah, so the bug that I caused was just because there's a couple of places, there's some weird files where either when it parsed the file, it found no interesting points to make a split, so it parsed it as a code, but it didn't find anything in that file to split on, or it it got to the very last interesting point, and then there's still bigger than a chunk left in the file. So those are the two cases that we're still tripping up on. So yeah.
Yeah. I
So
think
in
like
those cases now you would just use the size chunker instead of the code split. So it'll just split it into chunks of whatever, however many bytes.
that makes sense. I think also with the chunking, it's a bit of a struggle to I guess find all the scenarios where like all
Yeah.
the files that we might encounter with chunking. So uh
So
GitLab, the GitLab repo is kind of useful, I guess, in terms of testing it.
yeah. Yeah. I like ideally we would have test cases for every language as well. And all the tests are very boring like this. They're pretty much exactly the same. They're all just like some lump of code and the exact same session. So like in Go, I would just do a big um, table-driven test, but in Rust, I think you like have to make macros or something and muck around. I don't really know. I'm not much of a Rust dev, to be honest. But yeah. Yeah, it is really useful to be able to run it manually. But I had only just figured that out today. So yeah. I mean I could I used to before I got my new laptop I was pushing and waiting for the background jobs to run, but that was very tedious. Yeah. Well, sweet. I was hoping maybe some more people would come, but whatever.
Yeah, I think we're the only ones in APAC.
Yeah, well, I guess I'll post the recording somewhere. My awkward recording. Sweet.
All right. Thanks, James.
See you later. Bye.
Bye.